Hi guys, this is the first lesson of Chapter 9. Today we're going to be working with distance and midpoint formulas. So this is a prerequisite skill that you'll need all through Chapter 9. So we're going to be able to calculate the distance between 2 points after today, as well as we'll be able to find the midpoint of a segment that connects 2 points in a coordinate plane. Alright, let's start off first with the distance formula. Now this is something you will have to memorize. You're going to be asked to calculate the distance between 2 points without a calculator, so you can't, rely on a program in your calculator, and you also will have to be able to do this using mental math. Now basically what the distance formula states is if you have 2 coordinates here, defined as x1, y1, and x2, y2, to find the distance between these 2 points, you're going to take the difference between the x values and you square them. Then you take the difference between the y values and you square those and you add that together. Then you finally take the square root of the inside. Now this is a lot to try to take in, I think, because there's so many like little symbols here and you can really easily, mess this up. A lot of times students think that they should add these here on the inside, or they switch the signs. All sorts of mistakes can be made. So I do have something to kind of help you remember what that formula is supposed to look like. Okay, I'd like you to meet Distance Dan. This is a little mnemonic that I came up with like a couple years ago to help my students remember the distance formula in geometry, and they actually said this really helped, so it's really stupid, but hopefully it might help a couple of you guys, so I will show it to you. Okay, so Distance Dan represents the distance formula by a face, okay? So Distance Dan has a couple eyeballs, and you're going to draw his eyeballs like that. So this is telling you that the signs on the inside of those parentheses here should be subtraction. So we've got his eyeballs, and he's got, I guess, twinkles in his eyes, we used to call them. But they're probably wrinkles because they're outside of his eyeball. So we've got wrinkles around his eyes, okay? Those are the squared symbols here. He's got a nose. That's the plus sign here. He also has a toupee. And his toupee is the square root symbol. So there's Distance Dan. Kind of looks like a face, I guess. Not really at all, but maybe that'll help you. Now, all of that stuff is actually the hard part to remember. The easy part is plugging in what goes on the inside of these parentheses. It doesn't matter the order that you take your coordinates x1, y1, and x2, y2, as long as you just find the difference between your x values. So you can substitute x1 and then x2 here, or you can put x2 first and x1 next. It doesn't matter. Okay, so I put the x's in one parenthesis, and I put the y's in the other. Now I don't have to keep the order here the same either, so I could have written this on the other side as y1 minus y2. That would work as well. And now the reason why we're able to switch the order here of the x's and the y's is because if you take two numbers, let's say the numbers are 3 and 7, if you want to find the difference between these two numbers, you would take 3 minus 7, and if you square them, you would end up with a value of 16, okay? But let's say instead you took the difference by subtracting 3 away from 7 first, and then you squared that, well, you're still going to get 16. So no matter what I do, because I'm squaring this value on the inside of those parentheses, it won't make a difference if I rearrange the order here. Alright, so there's the distance formula. That's Distance Dan. Hopefully that'll help you remember it. Alright, so let's try number 1 from the note sheet. Let's find the distance between the 2 points. So we're going to work on part A only, and then we'll talk about the midpoint formula in just a second. So we want to find the distance between the points -3, 4 and 5, 2. So let's draw in our buddy Distance Dan's face. We've got eyeballs, okay? And he's got wrinkles in his eyes, or twinkles, I guess. I don't know. Whatever you want to call these. Maybe eyelashes. Somebody come up with a better reason for what those twos represent. Alright, then we have his nose, and finally his toupee. Okay, on the inside of those eyeballs, remember we're putting in our x values, we're substituting in the x values. It makes no difference the order that we put the x values. So if I take -3 here, I'm going to subtract 5. Okay, so I just take this coordinate here and subtract away that coordinate. And then in the other expression here, I've got 4 minus 2 squared. So what I'm doing mathematically is finding the difference between the x values and squaring it. Then I'm finding the difference between the y values, and then I'm squaring that, and I'm finding the sum of those two quantities. After I find the sum, then I square root. So it's not really hard to do the distance formula. The part that makes it tough is that students make little mistakes, okay? So a lot of times they forget that they plugged in, they'll forget the negative sign here, they'll drop it. Or if they switch the coordinate here, if they take 5 first, they just write this as 5 minus 3 as opposed to 5 minus a negative 3 on the inside of the parentheses. So again, it all boils down to mistakes, little mistakes with negative signs usually. And then also the simplifying is where people make mistakes as well. So let's talk about how we would simplify this. So the first thing you want to do here is actually evaluate the inside of the parentheses. So we end up with negative 8 squared plus 4 minus 2 squared is 2. So I'm going to square this, and then finally, after I find that sum, then I square root everything. So we have to make sure we pay attention to order of operations, because the biggest area that I see people make mistakes in is when they reduce from here on. So let's talk about what mistakes to avoid. When you simplify negative 8 squared, obviously this should always be positive. Your two values that you're going to add together should always be positive because you're squaring values. A lot of people will keep the sign here, they'll write that as negative 64, and they'll obviously mess themselves up a little bit when they simplify further. So anyhow, we get 64 plus 4, and then we're supposed to take the square root of that value. Well, instead of doing that, I have people who will split this radical up into root 64 plus 4. Then they simplify both parts, and they say that's 8 plus 2. So they get 10 as their final answer here so that they say the distance between these 2 points is 10. But their mistake here is obviously you cannot split that radical up like we did, because the square root of 64 plus 4 is really the square root of 68. Okay, and obviously the square root of 68 is not equal to 10. So we never, ever, ever can break up a radical like that. So please be careful about that. So instead, we have to make sure that we always simplify the inside of the radical first, and then we evaluate that radical, or we try to reduce the radical, I should say. So we take root 68 here, and we can split that up into root 4 times root 17. So if I reduce that radical, it's 2 root 17. Okay, so we just had a whole chapter on reducing radicals. This should be really easy for us. Now, rather than using this distance formula and having to write this out every single time, I do have another shortcut for you that you can use when finding the distance between 2 points. Now, this shortcut, make sure that you are accurate with this, that your mental math is really good, because if it's not, you're going to want to make sure that you show work. But basically, when you want to find the distance between 2 points, what you're really doing here is taking the difference between your x values. So what I want you to do, okay, is look at negative 3 and 5 and think about a number line. Negative 3 and 5 are 8 units apart on a number line. Okay, so that's 8 units apart. Now 4 and 2, these two numbers here, are only 2 units apart. What I do when I find the distance between 2 points is I take the difference between the x's and I square that, and I add that to the difference between the y's and I square that. Then I take the square root. So this is a shortcut for evaluating. If you notice, this is exactly what we got right here. We should get 64 plus 4. If we take the square root here, we get the square root of 68, which is going to reduce to 2 root 17. So this is just a little shortcut method. I'll do it once again in the next problem, but I just wanted to introduce it to you here for the first time. Okay, so now let's talk about midpoint formula. All right, so to find the midpoint between 2 points, x1, y1, and x2, y2, what you're going to do is find the sum of the x coordinates and cut them in half, and find the sum of the y coordinates and cut them in half as well. That represents the midpoint between your two coordinates, x1, y1, and x2, y2. So once again, there's an area here where students will mess up a lot, and it's because instead of adding these terms, they subtract them. And to me, that tells me, one, they're just trying to memorize things, but also they're not really understanding what a midpoint formula even does. When you add two numbers and you cut them in half, what you're doing is you're averaging the values, okay? So the midpoint between 2 points is really the average between the 2 points. So for example, if, whoops, that's not really a straight line, but here I'm on a number line, and I have the numbers 5 and 13, and I want to find the middle between 5 and 13. What I'm really doing is I'm averaging them. I want to find the average. To average two numbers, none of you, if I asked you to average two numbers, would get that wrong. You know exactly what to do if you have to average something. You add up all the parts that you have, so here I'd add up 5 and 13, and then I would cut that in half. So the average here is 9. So if I went 4 units left, I'm sorry, 4 units right and 4 units left, I'd end up right back at 9. So you're finding an average. So that's all that a midpoint formula really is. It's finding an average. So please make a note here that what you're doing is you're averaging. Okay, you're averaging the x's and the y's. And I think as long as you remember that that's really what's going on here, you probably won't get this wrong ever. Okay, I'm not going to say you'll never get it wrong because maybe you will, but I doubt it, okay, if you remember it as an average as opposed to trying to memorize a formula, because to me it's just as easy to forget something than it is to remember something. So that's why I don't like to rely on only, memorization. So you're finding an average here, and that's how I want you to think of this formula. All right, so for part B here, we've already answered part A with the distance. For part B, we want to find the average, so what we're going to do is add the x values. So we have -3 plus 5, which is going to give me 2. And then divide that value by 2. So I end up with an x-coordinate here of 1. Okay, and then for my y-coordinate, I have 4 plus 2. Find the average of 4 and 2. Oops, divide that by 2, and I will get 3. So notice that I'm not putting like a plus sign between the two averages here. I'm really finding a coordinate, so I should be putting those here in parentheses with a comma between. So your final answer here is not just a single number. Also, I will have students who write this answer as 4. They add the 1 and the 3 together, and don't do that. That really tells me you have no idea what a point is. So please make sure your final answer here is a point. It represents a point, whereas this over here should be just one real number because this is a distance. All right, let's move on to the next example. It says to find the value of x if the distance between the two given points is d. So in this case, we are finding x, okay? Notice we're missing the coordinate here. So to set this up, I actually do need to rely on distance Dan here. So let's use that. We've got the square root symbol here, his eyeballs, the nose, and the wrinkles in his eye, near his eye. Okay, so the distance here is represented by taking the x coordinates here, 5 and x, right? Subtracting those and then subtracting the y, so 3 and 1. Now the distance is supposed to be the square root of 22, so this value here is root 22. Now if I want to solve for x, that means I want to get rid of that radical first, but I want to try to get x alone. So I'm going to work on trying to get everything away from the x. So the first thing I would do, like I said, is square both sides. So if I square both sides here, that radical will completely drop. So now I'm left with just the inside of this radical. So when I multiply two radicals, so I'm multiplying this radical by itself, it's going to drop that radical sign, so I'm left with 5 minus x, that quantity squared, plus 3 minus 1 squared, so 2 squared. Now on the other side, that radical will also drop, leaving me with just 22. Now here you notice that I wrote that as 5 minus x. Remember, the rule with distance is you can switch those around because you're squaring this value, so it doesn't make a difference if you choose to put 5 minus x or x minus 5. So I'm just going to rewrite that in an easier form for me. I'll write that as x minus 5 squared. So I have x minus 5 squared plus 4 equals 22. Now at this point, I will have students who will incorrectly, it's not really incorrectly, but they make it harder on themselves than it needs to be because they will FOIL this out. Okay, they're used to foiling, especially from the last chapter, so they start right away by foiling this problem. However, if you think back to when we were working with quadratics, one of those methods that we asked you to use when you solved the quadratic was the square root method. And that's the fastest method for you guys to use and the one that I think you guys are the best at anyhow. So in this case, if I want to solve for x, I can use the square root method. Okay, I can isolate this term here by subtracting 4 to the other side. So the first thing I would do here is actually subtract 4 as opposed to foiling. Okay, now I end up with x minus 5, the quantity squared, equals 18. Now again, avoid the urge to try to foil the left-hand side here. Now just take the square root of both sides. So if I square root both sides here, I end up with x minus 5, right? That quantity here just becomes x minus 5 on the inside, equals, on the right-hand side, be careful, you have two possible solutions here, positive or negative root 18. Okay, so x minus 5, that quantity can equal either positive or negative root 18. Now we have to reduce root 18, so let's do that first. If I reduce that, I end up with 3 root 2. So I have x minus 5 equals positive or negative 3 root 2. Now to further isolate x, I need to make sure I get rid of that negative 5, so I'm going to add 5 to the other side. When you add 5, it's customary to put it in front. So I write that as 5 plus or minus 3 root 2. So these are the possible x values that I get. All right, so I want to talk about the reason why we actually have two x values here, two different x values. So if I plotted the points that they gave me originally, I have the point 5, 3. So it's about right here. And then I have another point where I don't know the x value, but I do know that the y value is 1. Okay, so if I come here and I look at all the y values that are equal to 1, that's, whoops, it's anything on this line here. Okay, now I'm supposed to be away from this line a distance of root 22. So think about square root of 22. The square root of 22 falls between the square root of 25 and 16. So it's between 4 and 5. Okay, so root 22 is approximately between 4 and 5. Now, that means that the distance from this point is between 4 and 5 units away. So let's say I'm really accurate. I'm really good at finding exactly where a distance of between 4 and 5 is. Okay, so I'm like right here. See how I have two possible choices? I could be going in this direction with that distance, okay, and end up here, or I could go in this direction and end up here. So that's why there's two possible coordinates. Now, I do want to graph these two possible coordinates. All right, so we've got the coordinate 5 plus or minus 3 root 2 comma 1. Really, this is, remember, representing multiple points, because we could take 5 plus 3 root 2. Let me erase the minus sign here. And we could take 5 minus 3 root 2 comma 1. So there are two different coordinates here. So one of the skills that you're going to use a lot throughout the rest of this chapter is being able to graph points like this. So let's make sure we're able to do that. Now, when you graph 5 plus 3 root 2, you're going to start at 5. Okay, so we would start here. You don't mark a point there, but that's where you're going to start visually. And then when you add a distance of 3 root 2, if this is not a value that pops out at you right away, if you're not sure how to get that value, I would go back to the original radical that produced that 3 root 2, and that was root 18. Okay, root 18 reduced to 3 root 2. So I'm going to look at root 18. And I know that root 18 falls between root 16 and root 25. So again, this value here is somewhere between 4 and 5 units. So when we graph here, the x value is going to be between 4 and 5 units away from this 5. So when I do 5 plus 3 root 2, I'm going 1, 2, 3, 4, and about 5 units away. Okay, so I'm falling somewhere in between there, and then I'm shifting up 1 unit. So there's where that coordinate would be. Okay. Now, I do the same thing when I take 5 minus 3 root 2. So I start at 5, and I'm going to go backward to the left. 1, 2, 3, 4, and about 5 units. So there's where my other point would be if I shifted up 1. Okay, so those are where the two coordinates are, and I know that it's kind of funny that all we're doing on that graph is drawing these 2 points in, but this is, like I said, a very important skill for the rest of this chapter. All right, last up we have number 3 here, which asks us to find the center and the radius of a circle. Okay, and the information that they give you is the fact that you have a segment, BC, and it's a diameter of the circle. So if we think about this visually and we draw a sketch of this, we have a circle with a diameter that's going to run through its center. Okay, so that's what's special about a diameter, right? So we have the points B, C that represent the endpoints. So we have some coordinate here, 3, -8, and 6, -4. Obviously, these are not where they would be graphed in a coordinate plane, but who cares? We're just drawing a quick sketch, okay? Now, if I want to find the center and the radius of this circle, well, the center here just represents the midpoint, okay, of B and C. So it represents the midpoint of points B and C. Now, the radius here is half of our diameter, right? So what we actually have to do here is find the distance between B and C. So if we find the distance between B and C, then we can cut that value in half. Okay, so we cut it in half to find the radius. Okay, now I'm going to use that shortcut like I showed you before, but I do want you to show the work when you do this shortcut, just in case you do mess this up, okay? So the shortcut comes in handy when you already have the points. If you don't have the points, then you need to use distance Dan. But if you already have the points, then the shortcut's really nice. So you're going to look at the x values, okay? And you're going to find the difference. Now the difference on a number line between 3 and 6 is just 3 units. And then you're going to square that value. Then you're going to find the difference between -8 and -4. Now on a number line, think about where -8 and -4 are. the distance between those 2 points is only 4 units. Okay, it's positive 4. So that's where students will make a lot of mistakes. They will write the distance here as like negative 12 and square that. So that's why I want you to show the work here, just in case you do mess up something like that. I will not give you credit for an incorrect answer if you don't have, if you use distance formula and you have some kind of small error, I'll probably give you partial credit. But if you're using this mnemonic here, or this little trick, and you get something wrong, I can't really give you partial credit. So anyhow, so try to avoid making mistakes. So we have a distance between negative 8 and negative 4, right? That distance is 4 units. So these numbers here are always going to be positive because you're dealing with distance. Now you're going to then square that value as well, and then you add those two together. Then finally you take the square root. So if we simplify here, we end up with 9 plus 16 on the inside of the radical. So we have the square root of 25, which is going to be 5. And again, please notice that if you had done it incorrectly and maybe you broke it up into root 9 plus root 16, you're going to get 3 plus 4, which is 7, and clearly not the correct solution. All right, so if we have a distance here between points B and C of 5, make sure that you take the next step here, which is to cut it in half, okay, to find the radius. A lot of students will forget to do that. So we have a radius of 5 halves for this circle. And for the center of the circle, we want to find the midpoint. So remember, for midpoint, sorry, I'm kind of all over the place with this scratch work here. For the midpoint, you want to average your x's. So if we average the x's, we're taking 3 and 6, we're adding them together, and we're cutting them in half. To find the average of the y values, you're going to take negative 8 and negative 4, and you're going to add them together and cut them in half as well. So this is representing that midpoint. So we have 9 halves, and negative 12 over 2 is going to give me negative 6. So I have a radius of 5 halves, and a center for this circle of 9 halves, comma, negative 6. All right, so that's it for today. 3 short problems. I know I took a little bit extra time to explain each one, but hopefully you're listening to all of the things that you need to avoid, you know, like the kind of mistakes. I'm sorry, let me rephrase that. So I hope that you're listening to all the little tips and tricks I'm giving you, because hopefully you can avoid the mistakes that I see constantly year after year after year. It kills me because people shouldn't be making these small mistakes, you know, well into the school year, but they still do. So try to avoid them, because I'll be so happy if you do. All right. Nice job. I will see you guys in class tomorrow.